Okay, so Swiflearn, as we always say, we try really harder. It's India's most sincere learning destination with classes from 1 to 10. So what's so special about Swiflearn? Let's see. So we are having 100% live interactive classes here. Interactive as in you will be having live classes wherein you can discuss your doubts, you can understand the chapters and all. Next, we have personalized attention. That is, in a batch we will be having maximum to maximum 6 students, so that we can attend you personally, right? Next, you will always have a dedicated academic mentor team to look after you and to help you throughout the session. And we cover your syllabus as per your school exam schedule, so that you can understand and you can both the courses can go parallelly. All right. Okay, and then there are some key features of Swiflearn, which are the detailed progress report. So what's so special in detailed progress report? Let's see. So the progress report is designed in a manner, it includes all your chapters which you have studied till now, and it depicts which chapter you are very good at, which chapter you need some improvement, and then you can improve accordingly. We also have Swiflearn academic test series wherein you can compete among thousands of your peers, and then you can see your position and improve that. Next is you can take unlimited practice test, and you also have subjective tests for your school exams. Alright, having said that, let's begin with our YouTube session. And before that, I would like to request you all to please subscribe this channel and press the bell icon so that you don't miss any update. Okay, so we were studying matter and its composition, wherein we completed certain things about matter, right? So we will be continuing that today also. We will be first revising what we studied in our last session, and then we will be learning many new things about matter. Okay, come on, let us start. So what are the things that we are going to cover today? First is the properties of matter. So we studied about matter. Now we are going to go through the properties and composition of matter, and at the last we are going to see some of the characteristics of the particles of matter. Alright, now let us start. We studied about matter, and we studied that all the living and non-living things are made up of matter. Okay, so it is the smallest unit. Okay, if I say a plastic, if I say glass, if I say wood, if I say mud, everything, it is made up of matter. Okay, this is the smallest unit of any particular thing. Next, if the question arises what is matter and how we can define it in a particular term, then it is anything which occupies space and has mass, and it can be perceived by our senses. So there are these three things which come into the light when I talk about matter. First is it should have mass. Okay. Next is it should occupy some space, and third one, it can be perceived by our senses. Taste, smell, touch, feel, etc, etc. So if we can perceive them, that is known to be a matter. Then we studied about types of matter. So how many types of matter do we have? Basically there are three types of matter, which are solid, liquid and gas. So this is the thing we completed in our last session, and today we are going to learn a bit more about these three states. Alright, so we studied that different states of matter, they have different properties. Okay, some of the properties we already completed in our last session. Okay, and some of the properties we are going to cover in today. First of all, mass. So if I say a matter has mass, what is meant by mass? The quantity of matter which any object possesses, it is called its mass. Okay, so if I say this pen, it will have some mass. If I say fan, it will have some kind of mass. If I say bottle, it will also have some kind of mass. So every matter, it possesses some kind of mass in that particular thing. Okay, and air, if I talk about air, so you will say air doesn't contain any mass, but that's wrong. Air is example of matter, and air also has a mass. So how we can prove it that air has mass? Let's see and do an activity to prove it. Okay. So first of all, what are we going to do is we will blow up two balloons of same size and tie those balloons at both ends of the stick. Okay, and then what we are going to do is we are going to tie a piece of thread in the middle of the stick and balance the stick. I'll show you a picture to make it much easy for you. Okay, so what we have done, we have tied it to a stick and we have blown two balloons of the same size. I think you can see it here, over here. And then we will be tying it with a thread, right? Okay, what will happen if the balloons are of same size? The weight will be same, the mass will be same. And can you see that a person is pricking one balloon with a needle? Okay, and when we prick one balloon with a needle, the stick, it bends to one side when the where the balloon is blown here. So what does it prove? The heavier thing, it bends to that side, which proves that air has mass. That is, this balloon is having a kind of mass, and that is why the stick bent to its side. Okay, so this activity proves that air has mass in it. Okay, so our observation was the air from one balloon which we pricked, it escaped out. Okay, and stick, it bent towards the air filled balloon. And why did it bend? Because the air filled balloon, it had mass, and heavier side, it moved down. Okay, so this was our observation, and conclusion from that, it was the air has mass. Next is the air occupies space. So this is very simple activity. Whenever we blow air into balloon, it inflates, right? It grows into its size. So therefore it is proved that air has mass and it also occupies space. So therefore air is a matter. And in fact all the matter, whether it is solid, it is liquid or gas, they all occupy space. Okay, so if I say matter, what is matter made up of? Can you think and answer? Let us see what is matter made up of. So matter, it is made up of tiny particles called atoms, which are the basic unit of every matter. Okay, so atom is the smallest fundamental unit of matter. An atom, it is very, very, very small. We cannot even see it through our naked eyes. It is the basic and fundamental unit of matter. Okay, so atom, if you want to define it, we can define it as atom is the smallest particle that has all the properties of matter. It is smallest and fundamental unit of matter. Okay, then if I say composition of matter, the atoms, they do not exist independently. Okay, they combine together to form molecules. So if I say molecules, what are molecules? Combination of atoms. So atoms, they combine to form what? They combine to form molecules, right? One group of atoms, they combine and form molecules. Okay, so molecules, they are the smallest independent particles of matter. Okay, we studied about atoms and we studied about molecules. Okay, so what happens in atoms? They cannot exist independently. Okay, these are the smallest particle of matter, but they are not independent, they are dependent. Okay, and if I say molecules, they exist independently. Okay, so many atoms combine in groups to form the molecules. Let us see some of the examples of molecules. Okay, first of all, it is made up of either same kind of atoms, or it can also be made up of different kind of atoms. Okay, see, if I talk about water molecule, what do we write water molecule as? We write it as H2O, right? So H here, it means hydrogen atom, and O depicts the oxygen atom. Okay, so H2O means two atoms of hydrogen and one atom of oxygen. They combine to form one water molecule. Okay, so here one atom is of oxygen and two atoms, they are of hydrogen. They combine to form a water molecule. Okay, so we are having in total 3 atoms which combine to form one molecule of water, in which 2 atoms, they are of hydrogen and 1 atom, it is of oxygen. Alright, so in theory it's very easy to make water from hydrogen gas and oxygen gas. What we have to do is we just have to mix the two gases together and add sufficient heat, that is energy, to provide them activation energy to start the reaction, and therefore the water it forms. Okay. Alright. Now, do all particles of matter possess similar characteristics? Now just think about it. Are all the particles of matter same, whether it be in solid form, it be in liquid form, or in gaseous form? No. Let us see how. Okay, so characteristics of particles of matter. First of all, particles of matter are very, very small in size. We cannot even see them through our naked eyes. Next, the particles are always in continuous zigzag motion, which is known as Brownian movement. And Brownian movement, it is also known as perisis. Okay, so this zigzag movement of particles of matter, it is known as Brownian movement or perisis. Next, we have kinetic energy. So the kinetic energy, it increases with increase in temperature. Whenever we provide heat to any matter, the kinetic energy in it increases, and if we decrease the temperature, it gets decreased. We've also seen this in the last class activity, in which when I was providing the heat to particles of matter, the zigzag motion, it was increasing, and when I was decreasing the temperature, the zigzag motion, it decreased, and the particles were in their own space. Okay. Next, let us see about some of the characteristics, which is the space between the particles of matter is called interparticle or intermolecular space. Now let us see, if this is one box which I am drawing, okay, and there are these various atoms, okay, which are tightly packed, if I say in the case of solid. Okay, so these are the atoms which are tightly packed, but can you see some of the spaces which are there in the between? Like, can you see these spaces? Okay, so these spaces, they are known as interparticle space. So this particular space, it is known as interparticle space because it is inside the particle. These are all the space, and it is also known as intermolecular space. So the space between particles of matter, they are either called interparticle or they are either known as intermolecular space. Next is the force of attraction between the particles of matter is called interparticle or intermolecular space. Okay, now if I say there is this is a matter, okay, and there are various atoms, okay, and what happens, there is a force which keeps the particles together, okay, so that force, it is known as interparticle or intermolecular space. So what is this force? This molecule is exerting the force on these molecules. This molecule is exerting the force on these atoms, okay, to keep them in their place, okay, and that is known as intermolecular space. Intermolecular force. And if I talk about intermolecular force, it is highest in the solids because the atoms are very, very tightly packed. Then it is in the liquids, and in the gaseous state we have least intermolecular force. Okay. Next, let's talk about two kinds of forces that we are having: cohesive and adhesive force. Okay, so the forces of attraction between same kind of particles, they are known as cohesive force if the particles are of same kind. Okay, like if I say water and water molecule, okay, so this is one water molecule, this is another water molecule. Okay, so the force of attraction which they will be experiencing, that is known as cohesive force. Why? because they are the same kind of particle. Okay, so same kind of particle, it is cohesive force. But if I say the force of attraction between different kind of particles, like if I say there is one water molecule and one oxygen molecule, so the force they will be experiencing, it is known as adhesive force. Okay, so if I say the force of attraction between same kind of particles, they are known as cohesive, and between different kind of particles, it is known as adhesive force. Okay, now intermolecular space and intermolecular force of attraction, they are inversely related to each other. Okay, so intermolecular space and intermolecular force of attraction, okay, these are inversely proportional. What do I mean by inversely proportional? If one increases, the other one decreases. Okay, let us see how. If I say gases, okay, so gases, they are packed very loosely, like one atom is here, one atom is there. Okay, so they are having this great intermolecular space, right? They can move very freely from one place to another. And since the intermolecular space between them is very high, what happens? There is no attraction between the particles. Okay, and therefore the intermolecular force of attraction, it is very, very less. Okay, let's talk about solids. So if I talk about solid, you can see the atoms, the molecules, they are very tightly packed in the solids. Okay, so you can see the space is minimum. Yes, in the solids, the interparticle space, it is minimum. So what will happen? All the molecules will exert a force on each other, on the neighboring molecules, to keep all the molecules on the place. So if the space is minimum, the force will be maximum. Okay, so that is how they are inversely related. Okay, so if the space increases, the force decreases. If the space decreases, the force increases. Okay, all right. So this is shown over here. If I talk about solids, so see, solids, the particles are very compactly packed. Okay, if you take a piece of ice, it is very compactly packed, it is not flowing here and there. So intermolecular space between them, it is very, very less. Okay, so that matter cannot flow here and there. Okay, so if we magnify, you can see it over here, the atoms are very, very closely packed. Okay, so they have a very less intermolecular space, and because of this, the atoms are very, very closely packed and they cannot move here and there. Okay, next if we talk about liquids, so in liquid the particles are loosely packed, not very loosely but loosely than in case of solids. So intermolecular space is just a little bit more than solids. Okay, and therefore the intermolecular force of attraction, it is less. Okay, not as much as that of solids. And if I talk about gas, so I told you the atoms are very, very loosely packed, the particles are very loosely packed, and hence intermolecular space is very much, and therefore the attraction is negligible. There is very, very less attraction, okay, in case of gases. Okay, so let us revise the intermolecular force and intermolecular space. So in case of solid, okay, if I talk about space, intermolecular space is very less. Okay, in case of liquid, the space is bit more than solids, okay, but less than gases, so they have medium space. And in the gases, they have a very good space between the particles of matter, they have large spaces. So therefore forces, if I talk about forces, the force is very high, intermolecular force, it is very high. Then in liquids, it is medium, okay, they are having good force. And if I talk about the gases, the force is negligible. Okay, why? Because the intermolecular space, it's very, very large. Okay, having said that, let's move forward. So let us revise what we studied today. First of all, we completed the properties of matter. So what do we have in properties of matter? First is it has mass, it must have mass, and second is it must occupy space. Third thing is we can perceive it by our senses. Okay, we can either taste it, see it, touch it, feel it, anything. But the most important properties are it should have mass and it should have it should occupy some of the space. Next, atom. Atom is the smallest particle that has all the properties of matter. And one of the most important thing is atom cannot exist independently. Okay, it combines. There are various group of atoms which combine to form a molecule, and then molecule exists. And two characteristics of matter. So particles of matter, they are very small in size. We cannot see it with our naked eyes. And next thing that we learned is about the kinetic energy. So kinetic energy, it increases with increase in temperature. So we can say kinetic energy, it is proportional to temperature. And how? If we increase kinetic energy, temperature will increase. Sorry, if we increase temperature, kinetic energy will increase, and if we decrease temperature, kinetic energy will decrease. Okay, so they are related to each other. Okay, and now let us come to some of the questions. Molecule. How can we define a molecule? So molecule, it is the smallest and independent particle of matter. Okay, if I talk about atoms, they do not exist and they cannot exist independently, but molecules, they can exist independently. Can you give me some example? If I say water molecule, okay, so in water molecule what we are having, it formula says H2O, which means two atoms of hydrogen and one atom of oxygen, they combine to form a water molecule. So this is how it combines to form a water molecule. Then Brownian motion. So if I talk about Brownian motion, this is the zigzag movement of particles of matter. Okay, and this is also known as pedesis. Okay, so Brownian movement, it is also known as pedesis. Next, let us differentiate between cohesive and adhesive force. So cohesive force, it is the force of attraction between same kinds of particles. Okay, and if I say adhesive, it is the force of attraction between different kind of matter. Okay, so if I have to give example of cohesive force, it is between two water molecules. Okay, so the force which they are experiencing between each other, it would be known as cohesive force. And if there is one atom of one molecule of water and one of oxygen, the force which they are experiencing, it is known as adhesive force. Next is intermolecular force of attraction. So the force of attraction which the molecules possess, which the molecules give on each other, it is known as intermolecular force of attraction. And can you tell me which particle or which state has greatest intermolecular force of attraction? So it is the solid. Solid has the greatest force of attraction. Then it comes to liquid, which has a bit less, and then it is gas. So intermolecular force of attraction, it depends on the interparticle space. So since interparticle space in the solid is the least, so therefore the force of attraction is highest in solid. Okay, and then liquid, it has a little bit less interparticle, a little bit more interparticle space, and therefore it has a little bit less intermolecular force of attraction, followed by gases. Alright, now interesting facts, the hardness of the diamond. So diamond, if I say, it is the hardest element present on the earth. So it is very hard due to the strong cohesive forces between the carbon atoms. So diamond, it is made up of carbon atoms, and the forces are very strong, therefore it makes the diamond hardest element present on the earth. Next, friction between two bodies, it depends in part upon adhesion. So when we keep two bodies on one another, there is a friction which we can feel, and that is due to adhesive force. and plasma is far by the most abundant state of matter in universe. Okay, the stars, they are mainly made up of plasma, and therefore plasma is the most abundant state of matter in the universe, because we are having millions and billions of stars, and therefore plasma becomes the most abundant state of matter. Now there is one question: when a stone is dipped in the glass containing some water, the level of water rises, but when spoon of sugar is added to it and stirred, the water level does not rise. Give reason. So I'll give you two conditions, like this is one of the glass and this is another. Okay, so it contains liquid. Okay, in one we have poured a spoon of sugar. So what will happen? The water level will remain same, but in one, if I put one stone, the water level will rise. Why does it happen? Can you think of it? Okay, so what happens? The sugar, it gets dissolved, right? It gets dissolved in the water. Okay, the particles of sugar get dissolved and they take up the interparticle space present in the water. Okay, since water is a liquid, it is having some interparticle space, and that space, it is taken up by sugar. Now sugar is taking all this interparticle space, and therefore the water level does not rise a bit. But if I talk about stone, stone cannot dissolve in water, right? It cannot take up the interparticle space in the water, and therefore it makes the level of water to rise. Okay, having said that, let's move forward and let's have the revision activity. So anything that has mass and occupies space, it is called matter. Water molecule, it is made up of hydrogen and oxygen atoms. So there are two hydrogen atoms and one oxygen atom. So these three atoms combine to form water molecule. The particles of matter, they are in continuous zigzag motion, which is known as Brownian movement. It is absolutely true. And the force of attraction between different kind of particles. So between same, it is cohesive, and between different, it is adhesive force. Alright. So here we are done with the chapter, and there are various things that we learned today. First is the properties of matter. Then we learnt about composition of matter, and at the last we covered some points about characteristics of particles of matter. Okay, so properties of matter, there are two main properties, that is, it has a mass and it must occupy space. Then we studied matter, it is generally existing in three forms: solid, liquid and gas. And then we covered various characteristics, okay, like intermolecular space, intermolecular force of attraction in the different states of matter. So I hope you all have understood whatever we have covered today, and thank you so much for being patient listeners, and let's meet tomorrow with a new session with some new things to learn. Thank you so much. Have a nice day.